Good afternoon, everyone, and welcome to today's webinar sponsored and presented by MAPEI, entitled The Shortest Distance Between 2 Points. My name is Sharon Schaller, the Member Engagement Manager here at NWFA, and I will once again serve as your moderator for today's webinar. And before we get started, I always like to go over a few items so you know how to participate in today's event. So if you have any questions for the presenter today, I need you to submit them through the questions pane of your control panel, and then we'll address them at the end of the presentation. You can submit those questions at any time while you're thinking of them, but we will save them towards the end of the last 15 minutes of the presentation. So throughout these webinars, we ask you a poll question, at least one. We only have that one for you today, and it is our one that we do every time to find out who is on this webinar. And the question is, what is your NWFA member business type? So would you please let us know who is on this webinar by selecting one? And as soon as I have enough of a majority, I will close that out and share those results with you. All right. Thank you very much, everybody. I'll close that and share those results. And we have a lot of inspectors on this one, Sam. It is 65% are inspectors, 13% contractors, 19% manufacturers, and 3% distributors. So I'll go ahead and end that. And now I'd like to introduce our speaker, our presenter for today's webinar, Sam Biondo. Directs the MAPEI Technical Institute's 3 U.S. branches, which provide training for contractors, distributors, and the A&D community. Sam has over 25 years of international experience in the flooring industry, encompassing all aspects of flooring installations. A popular speaker at many industry functions, including NWFA, Sam's expertise helps his audiences easily comprehend new and innovative technologies. So without further delay, let's get started with this presentation and take it away, Sam.
Thank you so much. Wow, what an introduction. I'm blushing over here. A couple of things. First off, I want to apologize to everybody about being late. That was on my end. We had some technical difficulties. You would think as many Teams meetings and Zoom meetings, go to webinar meetings that we've been doing over the last 3 months, that we would kind of have this down to a science. But my computer decided it would no longer wanted to participate. So we got it to this point where you can hear me. Unfortunately, you can't see me, or fortunately for me, you can't see me. This is an interesting topic for me. This was inspired by 2 different events. The first event was about 2 or 3 years ago at an NWFA convention. I was asked to sit on a panel of experts. That always scares me. And one of the inspectors asked me a question, and I really, now that I look back, I didn't answer the question very well. I wasn't satisfied or happy with the answer, and it really bothered me. And it helped me dig in a little bit deeper on how do I answer the question better. And the question was, how do manufacturers expect everybody to get 100% coverage with adhesive so they can maintain their warranty for these dual purpose moisture barriers and adhesive glue down systems? And I did a lousy job answering the question. I really did. I went back and kind of beat myself up a little bit, and then I did what I normally do. I started figuring out, how am I going to explain this better? Because there is a logical reason, and it was really simple. The answer is very simple. If I start off with a flat slab and I have a board that lays flat, you just need to use the proper size notch, and that 100% coverage will happen. Where you lose that coverage is when you don't have a flat floor or you don't have a flat board. And so all I can control as a manufacturer is I can help you get a flat floor to help the adhesive make sure that it makes the maximum bond to the back of the board. And that was the simple, shortest answer. And for some reason, I didn't answer it that way. So to that gentleman, if you are listening, I apologize, but thank you. You inspired me. The other reason that I'm doing this particular subject matter was a couple of months ago, we had an NWFA class here, and on sand and finishing, and I stopped the class and asked them for this particular presentation, what was it they wanted me to do? And unanimously, everybody talked about surface prep. And quite honestly, I would think, gosh, haven't we talked about moisture and surface prep enough? Guess what? The answer is no, evidently we haven't. So that's what we're going to do today. We're going to take a section of surface prep. We're going to truly understand what we're bonding to, because to prep the surface, we're either going to have to pour a self-leveler, or we're going to patch it, or we're going to do something to help smooth out and level and flatten this floor so we can go ahead and either nail it or glue down to it. So we're going to dive in deep today and take a look at some of the things that create problems and the reason things bond. It's a little simpler than what you think it is. And if there's any scientists or chemists out there, please forgive me for oversimplifying how concrete and how cement works. And with that, let's get started. So shortest distance between 2 points. You can say it out loud in your office if you want. That's right, it's a straight line. Interesting thing with that. We're going to touch on that in a second. We're going to go over the objectives and it's understanding level, square, and plumb. This is another thing that, fortunately for me, when I was coming up in the business, I learned I had to take a class as a carpenter. So I had to go to carpenter school and I had to go to allied flooring school at the exact same time. Tuesday night carpenter school, Thursday night allied flooring school. And I thought, well, this is the dumbest thing ever. Me going to carpenter school taught me how to read a plumb bob, taught me how to work with a plumb bob, and taught me the theory of 3, 4, 5, or the Pythagorean theorem. And literally the things that I can do with a plumb bob, a string, and a tape measure is off the charts. Because if you understand level, square, and plumb, if you understand by dropping a plumb bob down, it will create a perfectly straight line. You mark that line. You pick any point on that line and measure in increments of 3, 4, and then on an angle of 5. That will give you a perfect 90-degree angle. And from that perfect 90-degree angle, that's how you stripe a basketball court. That's how you check the square in a building. When I built basketball courts, it wasn't 3, 4, 5. It was 30 feet, 40 feet, 50 feet. And that's how we were checking the square of the building before we built the basketball court. So the basketball court sat perpendicular to the bleachers. And you didn't have game lines running underneath bleachers. So understanding level, square, and plumb, it was the fundamentals of building everything within our business. We're going to review flatness requirements found in industry documents, and we're going to look at methods for obtaining the flatness required. I like the word flatness. I wish somebody would have renamed self-levelers because they do level or help you get level. Self-smoothers would have been a better word. But today's thought, the shortest distance between 2 points is in a straight line in a 3-dimensional world. That's the world we live in, and that's the world we work in. In a 2-dimensional world, it's a little different. I'll give you a great example. If there was a chandelier above my head and I wanted to measure the distance from the bottom of the chandelier to the ground, I would take a tape measure, touch the bottom of the chandelier, and touch it to the ground. That's the shortest distance between 2 points, and I would measure the distance. That's in a 3-dimensional world. In a 2-dimensional world, I would measure from the bottom of the chandelier up to the ceiling, across the ceiling to the wall, down the wall, across the floor. That's a 2-dimensional world. We don't live in that. We live in a 3-dimensional world. So if you're looking at this picture right now, you're seeing that straight edge is 4 feet long, but the distance of the floor that's covering is not 4 feet. It might be 4 feet and 1/8 of an inch, or it might be 4 feet and 1/4 of an inch, because I'm going down that whoopty or that depression in the floor. One of the places that this was pointed out to me, and I always wondered about this, was when I installed VCT in the very beginning of my career. I did a lot of commercial grade VCT. We did a lot of hospitals, grocery stores, institutional buildings, things like that. And we always when we put VCT, like in the mop sink rooms, and the drains were recessed and beveled down, the tile would open up, and I couldn't quite figure out why that was always happening. I'm actually covering more distance as I'm going down that hill than if I was going flat. And the tile is a preset size. So when you're looking at these boards, for instance, in this picture that you're looking at, where that floor is not going to ever be as tight as it is right there at the bottom of that board, at the bottom of the valley or that undulation, because that board is not sitting square. And this is where that level, square, and plumb thing comes into play. The top part of that tongue of that board is touching right on the two edges, and it's touching linen, and it looks fantastic. But as that floor wears out, there's not solid material underneath there, and that's actually the weak link in this system. And it'll start to show an open gap, and now you think the floor is opening up. The floor is not opening up. The floor is not sitting square to the board next to it, and that's what's happening. So wood subfloor flatness, there are rules and regulations. We are talking about the subfloor. We're talking about the thing we're going to either nail onto or the thing we're going to go ahead and glue onto. For a wood subfloor, nail downs using mechanical fasteners of 1.5 inches or longer, flat with 1/4 inch and 10 feet or 3/16 and 6 feet. For glue down installations, mechanical fasteners of less than 1.5 inches flat to within 3/16 to the 10 feet or 1/8 inch and 6 feet. I have to tell you, there's probably 90% of the floors I worked on didn't achieve these standards, and it was up to me to go ahead and fix them. By the way, hint, hint to any manufacturers out there, since I work for one, we're all waiting for a leveler that you could put down over a wood subfloor and nail through without having an issue. Just saying. This picture made me really smile because I thought I was the only one who did stuff like this. I used to drive by dumpsters and pull out vinyl and linoleum. Old linoleum is great for this, on nail downs on the subfloors when they had little dishes and holes in them. And then I'd pull that old linoleum out of the van and I would cut it in smaller and smaller pieces to fill in the low spots before I went ahead and nailed the floor. So the only reason I added this was when I saw this picture, I was like, huh, I thought I was the only one, but I guess there's other people who went ahead and saw it the same way I did. It's nice to know that my thinking wasn't that far off base. Concrete subfloors, this is a whole, man, this is crazy. And you need to think about, and we're going to cover a couple of reasons why concrete subfloors can get so far out of whack. In a concrete subfloor, you want to make sure the slab is flat and this woodworking manufacturing specifications. Now there's Division 3 and Division 9 specifications. We deal in Division 9 specifications, but what's left with us comes from Division 3. So typical flatness tolerance of 1/8 inch to 3/16 and 10 foot. Not so much. I used to, when I built basketball courts, we used to check every 5 feet, we would check the floor, and we would use a transit for that. And we would make a stick, and we would go ahead every 5 feet and make a grid across that floor. And then with that grid, I would sit down with the general contractor and I could give him a valued price on how much material it was going to take to repair it and how to repair it, or did he want to do it. But these were the key spots where he needed to make the floor flat. So sometimes on larger scale jobs, which is most of my work, out of my 25, 26 years of installing, 20 of those years were institutional work. It was the last 5 or 6 that I started doing custom work, which, by the way, I really liked. It was a lot less brutal on you. This brings me to my favorite picture. I need you to look at that for a second. Anything? You have any idea what that is? That is a microscopic picture of a cement particle. We need to discuss how cement works. So we're gonna go back. We're gonna go back one slide. That stuff right there, that gray stuff that straight edge is sitting on, that's concrete. Concrete is cement is the paste, and then there's an aggregate inside of there. And the aggregate is a rock, and depending upon how thick you go determines the size of the rock or the gravel or the sand that's inside of there. Like for instance, in self-levelers, there's a fine grain of sand in there. In skim coats, there's a really super fine grain of sand, but all of that is the aggregate. The binder is the cement, it's the paste. That's what glues and holds and locks everything together. All the other stuff that you put in there is either accelerators or retarders, and that either slows it down or speeds it up, and the aggregate. So we'll go back. When you're looking at this picture, you see these little spikes, these little fingers. This is ettringite. It's a big word for me to say. Don't ask me how to spell it either. I'm terrible at spelling. But this is ettringite, and ettringite grows these spikes. This is Portland cement, and inside these Portland cement particles, if there is such a thing, it grows ettringite when it comes in, when it's mixed with water, and these fingers interlock together, and that's what gives cement paste strength. And then depending upon how thick it is will determine whether that cement paste is wrapped around a grain of sand or a giant rock, depending upon how thick you want to go. But you'll notice, you'll see those spikes. Now in between those spikes, you're going to see these little blank spots. Those are pores. Now, when we initially manufacture a product, a cement-based product, we're going to automatically add 30% more water. This is a really good time for me to tell you, measure your water, because the manufacturer has already figured into it extra water. That extra water is called water of convenience. That water of convenience is for you to go ahead and allows you to place it and push the material around. If it's a self-leveler, allows you to pour it out. If it's a patch, allows you to trowel it out. But that water stays inside for a little bit. These cement particles grow these spikes, and the water's trapped in between there. As the spikes grow, they push apart. So there's an initial growth or expansion of a cementitious product. Then as the water evaporates, and it evaporates through these pores, it pushes the cement particles apart and creates these pores and tunnels. And now the water leaves those blank spots, and the pressure comes off, and it starts to pull back in. Now the concrete or the cement is shrinking. This process on a concrete slab 4 inches, 28 days, it's pretty much 70% cured or dried. It takes another 100 years for that last 30% to get out of there. And the reason being is, as it's getting out of there, the escape routes, the pores are getting smaller and smaller. And so it's harder and harder for the water to get out of there. And then as the water escapes, it shrinks up a little bit more, which makes it smaller. It also, as that happens, it gets stronger and stronger. A great example of this is go to a slab that's 28 days old. You can take a cut nail and a hammer and drive the cut nail right into the concrete slab. You go to a slab that's 28 years old, you have to drill a hole before you put a cut nail into the slab. Go to a slab that's 50, 60, 70 years old, you burning up your drill bit trying to drill the hole to put in the cut nail, because that concrete is pulled back in and all of those voids are starting to fill up. This is a cement particle. This is a cement particle. Now, if you notice, they're like snowflakes. They don't always look the same. And a lot of this has to do with what kind of cement it is and what I'm asking the cement to do. But when you look at these pictures, the one thing you see is those little spikes all interlocking together. That's what gives concrete and strength, and concrete its strength and its flexibility. You start breaking those fingers off, and that's how you break up and crumble concrete. On this last picture, this is kind of interesting, because when you look down at the bottom part, you see kind of like, it looks like a rubber band that's going across there. That's bonded, and the particles are kind of stuck to it. That is the thing that you pay for when you buy product from a manufacturer. That's latex. That allows those particles to flex a little bit and come back to their exact position so they line back up. But you need these pores. You need this porosity, because if and when I go to bond to this cement structure, if I don't have these pores and I don't have this porosity, this is going to be a problem. So there it is. That's it in the big picture. I love that part of that picture up in the top right-hand corner. That's got nice long spiky spikes, and it all goes together. And that is a piece of lime, that circular plate looking disky thing. I checked with the scientist on that, by the way. That's a piece of lime in there. By the way, probably if you ever get efflorescence, that's where it comes from. That gets wet, breaks back down again, and starts leaching its way up through the pores in the system. So you're thinking to yourself, oh my gosh, is this a science class? Well, I have news for you, man. What we do, we are construction artists, but what we're working on top is, big word, very scientific-y, especially in this day and age. And this is why it's important to follow the instructions on the bag, because the science is in the bag. The days of you and I getting a pile of sand and a couple of bags of straight cement and us making our own magic on the job site, they're kind of over with. Hey, look what just came on. They're kind of over with. So this is the next thing. You know what that is? That is after this concrete or the cement has dried, those are the pores. Those are the microscopic pores that are on top of a surface. Here's another picture of it. This is really interesting because the different colored aggregate that you see in there, and everybody's aggregate is different. The different color aggregate that you see in there, that's up to your location, where you're from, where you live. Not everybody's aggregate's the same. The aggregate we use in Florida is different than the aggregate that you use in Tennessee or New York or California or Washington. It's different. But in this case, I want you to look at that picture really carefully. Any place you see the gray, that's the cement paste. And this is a piece of concrete that's been cut out and then ground flat on the side. So now you're getting a perfect view of this, and we're cutting right through the rock and everything. You see the gray paste, and inside of the gray paste, you see a bunch of little holes and dots. Those are pores. But I want you to look at the aggregate, especially the two big pieces. There's the big one up in the upper left-hand corner. There's the big one on the bottom right-hand corner, and there's kind of that half moon one in the middle. Look at all the pores just that piece of aggregate has. So that's going to pull and wick a lot of the water out of whatever you're putting on top of this out faster than in the other areas. This could create a problem on your bonding. Now, this has nothing to do with you. You didn't pour this concrete slab. This is not your fault, but it can be your responsibility. Because when you show up on the job and you pour some water on the floor and you see that water disappearing really fast, you should be a little nervous. And when I say really fast, it should flatten out and go away in about a minute or two, not in 10 seconds. But I just wanted to show you this because sometimes it's not your fault. Sometimes the difficulty to bonding to something is because the aggregate that's in there is way porous and it's drawn all the water out of what you're trying to bond on top of. And I think this is the last scientific-y picture we got here. This is a microscopic picture, and you can see the capillary pores. Now, there are pores for different reasons, but the pores that we're concerned about are capillary pores, which means that the water, that this whole thing was mixed together, the cement particles grew their spikes together, and now the water needed to get squeezed out of the system and rise up to the top, push the particles apart a little bit, and created these tunnels or these pores or these passageways. We need these to bond. Not to be outdone, this is a microscopic picture of oak wood, and these are the pores. Now, the reason I show you this is I know it's oak, and I probably wouldn't use oak as my subfloor, but it was the best set of pictures I could find that represented wood. Wood has pores in them. And so I'm showing you all of this because right after this, and I'm probably going to come back to these pictures, we're going to talk about how you bond to this, how things bond to that, and what the process is that happens that you need to know about. So there are specifications, how flat. The American Concrete Institute says specifically, let me move this, guys, because I can't, specifically says the floor flatness requirements and levelness requirement. The higher the number, the flatter the floor. And so these are the FF numbers. Now, I like the FF, but here's the problem with it. The FF numbers are checked 72 hours after the concrete is poured. There's an awful lot of water inside of those pores still at 72 hours. You, the floor man, might show up anywhere between 30 days and 90 days or 9 months after the concrete is poured. And so that concrete structure has gone through a metamorphosis at that point in time. Or let's take a wood subfloor. That wood subfloor could have got wet after they checked it, and then it got wet, and now it could be buckled and warped. Something could have happened. Like somebody left a window open, a tree fell through a window, a hurricane. I live in Florida. A hurricane could have came through. A lot of things could have happened, and then you're one of the last guys on the job that show up, and they go, "Yeah, no, we checked the floor. The floor is good." Yeah, you checked the floor 8 months ago. But a lot of things have gone on this job site. There's a lot of moisture been introduced to the job site. Now all of a sudden, theoretically, they're supposed to turn the air conditioning on, which is going to wick the moisture out of the room. So it's kind of like going on a 72-hour cleanse. The AC goes on, and you go from a certain amount. You go from 50% relative humidity to 30% relative humidity in the room. Or in the case of Florida, you go from 80% relative humidity to 50% relative humidity in the room, and all the wood is losing that moisture and is shrinking up and moving and changing. All of this impacts your ability to bond to the top of that. This is the ASTM standard F710. These are the F numbers provided architects and contractors. And again, there's a place for them, and you probably need them, but they don't help us in the long run. We are still responsible for checking that slab. Don't assume because someone else gave you the numbers and everything checked out that it's good to go. It's up to you. I always use this analogy. If my dog jumps the fence and bites the neighbor, it's not my fault, but it's my responsibility. If I open the gate and tell my dog to go bite the neighbor, it's my fault and my responsibility. When you show up on a job and the floor is out of whack and you just go ahead and install on top of it and the floor fails, it's your fault and your responsibility. It's your responsibility to check that floor and start the process with the contractor. Now, I know what you're saying. They don't want to hear it. They don't want to be hit with change orders and all of that stuff. I don't know what to tell you. If you want to battle a crooked, wavy, uneven floor, you go right ahead. And if you want to assume that risk, you go right ahead. That's up to you. But I'm telling you, that's not your responsibility. It's your responsibility to check it. It's not your responsibility to go ahead and fix it for free unless you wrote that into the contract. And this is why when you find good contractors, general contractors, you like to work with them because you have an established relationship. I like to go out to jobs way beforehand, just do drive-bys, walk onto the job, check, take a look, see if something looks weird, and bring it to the contractor's attention so you can start the conversation early. Self-levelers are a really good way of fixing and preparing subfloors and getting them flat. With a self-leveler, you're going to be in what we call the very flat to super flat range. And one of the advantages of working in South Florida when I started doing custom residential was in the 60s, in the 50s, 60s, and 70s in South Florida, almost all the houses down here were single level and the floors were terrazzo, cement terrazzo. And if you know anything about how terrazzo works, it's a cement product where they put crushed up marble chips in there, and then they grind the floor flat to expose the ends of the marble chips, and then they seal it. Well, by going ahead and going over a terrazzo floor and gluing down a wood floor over top of a terrazzo floor, that floor was almost perfectly flat. You used 10, 15% less glue, You didn't fight the floor. You weren't fighting bumps in the floor. You weren't fighting undulations in the floor. That floor just went right in. It was an easy install. It went in faster. It went in cleaner because you used less glue. It was just an easy, it was an easy job. I looked forward to doing that. There were several terrazzo floors that I refused to put glue over top of because they were absolutely stunning. And what happened in Florida was the reason that you had terrazzo floors was before air conditioner were in every house. A terrazzo floor was a great way to retain coolness in the house in the summertime and radiate back up at night. And then this big trend came into wall-to-wall carpeting, and everybody put carpeting over their terrazzo floors, and that sat like that for 20 or 30 years. And then we started buying up houses, these houses, ripping that up and either putting in ceramic, marble, or wood floors over top of that. And that's when I started seeing some floors. I saw some amazing terrazzo floors that were in all black with seashells embedded in them. I refused to install anything over top of that. I thought the flooring gods would never forgive me. Traditional FF numbers typically are measured 72 hours after it's poured. They don't factor in the curling of the slab and the end joint effect. What starts at a 1/4 inch and 10 feet can be more by the time the flooring installer gets there. You know, the way you need to think about a concrete slab that's been poured is think about a sponge that you clean your dishes with. Go ahead and take that sponge, get it good and wet, wring it out, take it and throw it underneath your sink, and come back and look at that sponge 2 weeks later. It's kind of curled up on the ends and pulled up. That's what concrete is doing over the course of time, over 30, 40, 50 years. It's shrinking in on itself. It's getting smaller in on itself and pulling in, and kind of the ends where the saw cuts are there because they know it's going to crack and they want to control the cracking, and it's going to crack there. And they peak up and they kind of bow up a little bit. And over the course of time, older concrete slabs can really be a challenge. You don't, when you necessarily, you think sometimes you want to grind things down, especially on the edges where the saw cuts are at. But if that slab is 50 or 60 years old, you want to be careful about grinding down those edges. You might grind down an inch of material in some cases. And now you took a 4-inch slab and turned it into a 3-inch slab. You've affected the structural integrity of that slab. So anytime you're working with a concrete slab that's 40, 50 years old, you might want to contact or have the general contractor or the homeowner or whomever, you might want to get in contact with somebody, an engineer, about how to handle fixing and leveling and truing up that slab. Flooring installers should assume when bidding that the floor won't be flat as an industry standard requires it to be. Seriously, guys. We should not be surprised that when we show up on a floor, it's not flat. ANSI requirements require, and the ANSI is American National Standard Institute plywood. I need to move this thing. Typical issue with wood is a 1/16 of an inch requirement in relatively small areas can be quite a bit. Modern building practices, there's OSB construction exposed to moisture prior to building, wider joint spacing, less tongue and grooved plywood. All of these things are impacting what's going on a job site and that subfloor that you're asked to go ahead and install on top of. You know, OSB is kind of an interesting beast. I know most of the country has OSB. In South Florida, after Hurricane Andrew, they started experimenting. Before Hurricane Andrew, they started experimenting with OSB and wood framed houses. And almost all the houses that you saw pictures of on the news that were sticks laying on the floor were these OSB houses, where there was 2x4 construction, OSB siding on the side of it. And when they forensically went ahead and looked at how these houses fell apart, the OSB got wet. And once that happened, it expanded in multiple directions. Because what is OSB? I always think of OSB like mulch. And so at least if I have a piece of plywood, the grain is running in one direction for every layer. With OSB, that piece of mulch, they're all facing in opposite multiple directions, and they're not the same size. So some pieces are bigger than others, and so they're expanding in one direction, whereas something might be expanding in another direction, not quite as much. And OSB in South Florida is just kind of a no-no. We use it maybe as a filler board to build height or something, but we always finish off here with a CDX plywood. But I get it. I totally understand that in other parts of the country, OSB is used. You want to go ahead and try to put something on top of that if we're going to direct bond the OSB. You don't want it to absorb any water. So we're going to seal it with a sealer, and then you can go on top, unless we're going to use some sort of glue. You want to also check, and I'm going to tell you this right now, check with the manufacturers, check with the manufacturers of the adhesive, check with the manufacturers of the wood floors. If we're nailing down, you want to check, and I'm sure you guys know better than me, you know the standards for this, but check. Make sure you understand, check with the manufacturers, check with the NWFA, and make sure that the substrates that you're bonding to are good to go. Best way to go ahead and take out high spots on concrete is grind them. Find the areas where they're not flat and grind them. This is a great technique. I love this picture of this guy in here because I don't know what that hose is doing coming out of that grinder. Any grinding that I did when I was back in the day. And by the way, I just want to say this out loud because I don't want to pretend like I am on the cutting edge of installation. I haven't installed professionally in 19 years. I want you to understand that. That doesn't mean I'm not an installer at heart, but in 19 years, I haven't installed professionally. I've worked at MAPEI for 17 years. And prior to that, I ran a shop for 2 years. So a lot of the things that I see about installing, some of these techniques are kind of new to me, but it doesn't mean that I don't know how to do them. But I just want to be honest with you. I haven't installed in 19 years, and I feel I am an installer at heart. I feel for installers. High spots are ground down with a diamond blade and a rotary grinder. Low spots are built up with patching compounds. Sometimes it's just a few whoopties and high spots on the floor, and you get in there and you fix it and you knock it out. Sometimes it's a disaster, and it's easier to go ahead and cap it off and pour it with a self-leveler. Self-levelers are products designed to flow freely, develop high compressive strengths, and they flatten out. They flatten out pretty darn close to where you need them to be. I have to tell you, and better quality self-levelers flow better. A little trick when you're looking at a self-leveler, you can tell how good the self-leveler is by looking at that edge where the self-leveler is flowing across the primer on the floor. The thinner that edge is, the better the product is, the smaller the aggregate. But when you're using small aggregates, there are restrictions to how thick that self-leveler can go. Now, here's an important thing. In this picture, we're seeing this room here. If that floor had pits or holes in it that were 4 or 5 inches deep, you just don't continue and pour self-leveler over that. You're going to have to address those holes first, and then you pour the self-leveler to smooth over top. That would take that self-leveler beyond the scope of the depth that it can be used at. You want to read instructions. This is why companies have multiple self-levelers. They don't just have one. They'll have several. In our case, we have a plethora. And some of them are designed to be normal setting or rapid setting. Some of them go from 1/8 of an inch up to 2 inches. Now we have self-levelers that can go up to 4 inches. We like 4-inch self-leveling pours, in case you were wondering. We think that's the future. Just kidding. But yeah, you just know how deep you need to go and then choose the appropriate self-leveler based on that. When you use self-leveler, floors that require significant correction. On concrete plywood, typically OSB without additional preparation. Leveling one type of subfloor. Over radiant heat systems, large areas, and when time is critical. When I was a commercial grade installer, the largest self-leveler job I ever did was 158,000 square feet. It had to be done 24/7 around the clock. That was part of the specification. There could be no cold joint in it. So we designed a way that we had 3 crews. We brought trailers onto the job, and literally we just camped out on the job for a couple of days while we had self-leveling pumps, just pumping out self-leveler and going nonstop. And the crews just rotated in and rotated out. Smaller jobs, 100 square foot bedroom, you can mix self-leveler in a 5-gallon bucket and then go ahead and pour it out and handle it yourself. But typically, anything past a couple of 100 feet with self-leveler is not a one-man operation. It's usually a 2 to 3 man operation. I had a crew of guys that's all they did in front of me. And there are companies, that's all they do. They'll go and pour and surface prep these bigger jobs before you get there. So when you get there, you just snap a line and you start installing, which is the one thing I love to do the most. So understand, I mean, if you're not good at it, if you're not competent at self-leveler and at patching, look for a company that is and just include that into the bid and into the price. Cement-based self-levelers, there's gypsum-based self-levelers, there's rapid setting self-levelers, there's lightweight levelers, there's levelers for thin caps, there's reduced surface prep self-levelers. What does that mean, Sam, reduced surface prep? Well, for the most part, most self-levelers require you to shot blast, or they require some sort of scarification. They need you to rough up that surface, okay? Reduced surface prep self-levelers, not so much, but you're gonna pay for that. But they mix, you'll mix in, they're usually 2-part systems. You get a bucket of liquid and you don't just mix them with water. You mix them with a bucket of liquid and the bag, you mix them together and you go ahead and put them down. There's moisture resistant self-levelers. There's levelers that don't break down or very highly moisture resistant under damp conditions. Typically, like I said, this is not a one-person job. Requires some specialized tools, gauge rakes, porcupine rollers, smoothers. Some companies have grout pumps where they mix into the self-leveler for bigger jobs and they pump them out. And you have a guy just gauge raking the product out, and then a guy coming right behind him with a smoother and smoothing the whole thing out. And planning is the key. And I'm back to the question that I asked in the beginning. Shortest distance between 2 points. I thought I heard somebody say it. That's right, a straight line. And in a straight line, that would be a flat, smooth floor. When you look at this bottom box down here, one of the reasons that you want to put a profile or a texture on a concrete, if it doesn't already have it, that you're going to pour a self-leveler or patch onto, is it creates more surface area. You see those little mountain peaks and those little valleys and stuff like that? Think about it like this. If I took a piece of string that was 2 feet long and I stretched it out and I measured it, it's going to be 2 feet. Now I mark where the end of the string is and I mark where the other side of the string is. That's exactly 2 feet. Now with my finger, I start pulling the string down and pushing the string up, basically creating these waves in the string. As I'm doing that, the string is pulling away from those lines. And so I have these ups and downs, these valleys. Okay. If I have these ups and downs in these valleys, there'll be more surface area on the bottom than there will be on the top. This will help and aid in the bonding of the product to the surface. Next thing it's going to help and aid in the bonding is that all products, everything, absolutely everything that you bond on top to requires, in this case with self-levelers, requires a primer. Shot blasting on larger jobs is the best way to go ahead and clear up and get anything out of there. Now remember the pores that we were talking about earlier on this concrete slab. You see the shiny side of this picture right here. There's some sort of sealer or something on top of that cementitious slab that's down there. That is in and blocking the pores. This is the part where we explain now how things bond. So you remember the concrete slab and how you had the spikes, and then the spikes pushed against each other and water was trapped in between those spikes, and then the water evaporated and created these pores or these tunnels and passageways up to the surface and left these holes. And we saw those pores in those other pictures. Now, when I go to bond something to a cement slab, if those pores are opened and I'm going to go ahead and put a glue down, or better yet, let's just go with a patch. I'm going to go ahead and put a patch down over top of that. The water that's mixed with the cement particle in that patch gets pulled down into the pour and drags down the cement particle in that pour with it. And then that cement particle grows its spikes inside of those pores. And that's how it anchors itself and bonds to the top of that slab. If these pores are blocked, like in this case with this shiny sealer that's on top of there, it's filled up the pores. And now when I go to bond on top of there, nothing's penetrating down, everything is laying on top, and it's going to kind of shear off, and you're not going to get a good bond. People ask me all the time, can you bond to this sealer? And I said, my answer is all the time, get some water, pour it on the floor. If the water penetrates, you can bond to it. If the water doesn't penetrate, you're going to have a hard time bonding to it, or you're going to have to come up with another way of bonding to it. You're going to have to make a chemical bond to it at that point. So the pores are very important. The other aspect of it is when I'm skimming a floor with a skim coat and I've got those pores, as I'm pushing that trowel across the top of that surface, it's mechanically pushing down the cement particles into those holes and into those little valleys, and then they grow the spikes in there, and that's how things lock up. And that's how you bond. When I'm going to go ahead and put down, let's just say adhesive, I'm troweling it down and I'm pushing it down into those pores. If it's a water-based adhesive, I'm troweling it down and pushing it into the pores, but also the water's getting pulled out of the water-based adhesive and grabbing the sticky stuff and pulling it down into those pores. That's how you bond. If the pores are blocked, you can't bond. So you have to make sure that you have the ability for water to penetrate. It's a drop test. That water will penetrate into the surface that you're trying to bond to. If not, pick up the phone, call your rep, call a rep, whoever's product you're using, tell them you have a problem and find out what product they want you to use. Levelers can flow like water. I want to caution you on this right now. When you're doing a self-leveler in a multi-story building, don't assume that because there's a wall, there's no holes underneath that wall. You ever been on a commercial job? They drill holes through the wall and the hole is maybe 1 inch or 2 inches around. It's covered by the wall, and then they put a 3/4 inch pipe through that hole, and there's a big gap there. If the self-leveler runs underneath the wall, it will spill out down through one of those holes. And I know that because I was working in a high-rise building, office building, and we were pouring leveler, and the guy kept complaining that for some reason the leveler was disappearing, which made me stop and take a look at what he was doing. And by the time I got over there, I realized it was running down the wall to the floor down below onto the drop ceiling. We ran downstairs and got the person that we thought was sitting underneath where the leak was at out of the way just in time when the ceiling crashed down and spilled concrete all over her computer. Thank God I had insurance. Almost all self-levelers require primer. Guys, I can't emphasize this enough. I know it's not in our gene to do this, but man, you gotta go ahead and you gotta read the instructions. You want to do what the manufacturer wants you to do with the product. Nobody knows his product or their product better than they do. And if you don't like what the manufacturer is telling you, then maybe you need to consider a different manufacturer. But you've got to read the instructions. You've got to follow the instructions of the manufacturer. So use the primer that they want you to use, and use the material that's right for the job. Use and do it the right way. Read those instructions. And I should bite my tongue in saying this because I'm probably, when I installed, I was probably the least instruction reading person on the planet. But as I've worked for a manufacturer and I see these claims that are silly, that could have been avoided had somebody read the instructions and just followed the instructions, it kind of hurts me to see how many claims are, from a manufacturer standpoint, are denied, or is the installer's fault or somebody's fault who didn't follow the instructions. So just read the instructions, man. They're there for a reason. Our instructions come in 4 languages: English, Spanish, French, and then we put man pictures on all the packaging because we know you're probably not going to read any of the other 3 languages. So look at the little pictures and try to and just follow what's going on the packaging. Here's the other thing I'm going to tell you. If you're going to overwater any product, please don't let it be self-leveler. Self-levelers are the miracle of the construction business when it comes to cement products. You have no idea how technical self-levelers are to manufacture and make. You see, when I add water to a cement particle, the cement particle absorbs the water and starts to grow the spikes. The second it starts to grow the spikes, that's called the initial set. At that point, whatever is going to be placed, the self-leveler or anything placed on top of it, it should have already been there. If it wasn't already there, then it's not going to bond because the spikes have already started to grow. So the self-leveler, you add too much water, it's going to go ahead and overwater the product. In self-levelers, we slow down the process of the cement particle being able to absorb the water and grow spikes, and that allows it to flow out, and then the water evaporates and that allows it to lock up. That's why after about 7 minutes, you want to make sure you're done pushing around self-leveler after you've poured it out. If you overwater it, it'll lead to soft and powdery surfaces. I'm going to tell you this right now. There's 128 ounces of water in a gallon. And I tell you that because if you don't have a gallon measuring pitcher, you've got something with ounces marked on it. Do the math and follow the manufacturer's instructions on the amount of water. Smaller areas can be poured from buckets. Larger areas can be pumped. Pour areas with a wet edge. You always want to pour self-leveler into the wet edge. You don't want to, it's like making pancakes. I want to make one giant pancake. I don't pour pancake batter on one side of the pan and the other. I pour into the middle and let it flow out. Porcupine rollers, they break up the tension. I like porcupine rollers a lot. And if you're not familiar with any of these tools or anything like that, man, pick the phone up, call a leveler manufacturer, have the tech rep coming out and show you. You don't have to buy anything, but have them show you. And the other thing, do what I do. Anytime I don't know something in the business, man, I Google it and then I just start learning. And then I go check it out and I ask guys that work with it and I find out. I kind of had to speed up at the back end there. We're running a little bit out of time. Guys, I want to thank you for listening. I am open for questions if we have enough time.
Wow, that was great, Sam. Very good, very good. I didn't know there were flooring gods. I really didn't. Well, let's get going with some questions here.
Their name.
You're kind of breaking up a little bit, Sam. What did you say?
I said I don't know their names, but of course there is. The flooring gods.
I know there are some. Okay, so again, you guys, if you want to answer any questions, anything at all about this subject to Sam, please submit these questions into the questions pane. But I just have one remark, and he says, probably the best presentation and explanation I've viewed in a while. So thanks, Rick says. So you probably explained it so well, there aren't any questions. So guys, if you do have any questions, quickly put them in and Sam will answer them for you. And so, yeah, we're right at close to 3 o'clock, but we do have time for a few questions. So ask away, guys. I hope it's working. Because normally there's a ton of questions for you, Sam, but you really did a great job.
Thank you so much.
So,
this has been it's been a learning curve for me, like coming out of the field and then going to a manufacturer. I got to go into a laboratory and ask chemists and scientists a lot of things, which helped clear up how all of this works in my head. So it's an advantage. By the way, I mean, if people get a chance, when we get back to giving live presentations, come on by, a MAPEI presentation, and we host NWFA presentations at our facilities all the time. And
well, thank you. Got another comment from Scott. Fantastic presentation, super informative, and thanks. So thank you, everybody, for joining us. Thank you, Sam. I just want to thank you again, and thanks everyone for attending today's webinar sponsored by MAPEI. If you have
Thank
any other questions, so if you see any, you're maybe rewatching the recording, you have any questions that you come upon maybe later, you can always go to Sam. Your information is not there. Sam, what is your email address so you or your number, anything that you have that you can share with the guys?
Okay, so my email address is my last name, BIONDO @MAPEI.com. S as in Sam, B as in boy, IOND as in dog, O @MAPEI.com.
Wonderful. Wonderful. Hey, and once you leave today's webinar, you will receive a survey on this presentation. So we want to hear your feedback, whether it's any bad ones, good ones, in between,
Right.
all of them. We want to hear them. So we want to always be better at these webinars as we go along. So you
Sharon,
will also, yeah, go ahead.
Just one last thing for anybody still listening. In your comments, if you want, let us know what webinars you want to hear going forward in the future. Like, we think we know what you want to hear. You guys, it's just we're the messenger. Just tell us what you need to hear to help make your job and make the install business and make our business better. So just let us know.
Thank you. All right, so NWFA will continue to host these free webinars on the second Wednesday of each month from 2 to 3 Central Time, with an occasional webinar on the fourth Wednesday of the month. So on behalf of NWFA and MAPEI, and Sam, thank you for joining us today. Stay healthy and have a great rest of your day, guys. Thank you.
Thank you very much.